Have you ever wondered what would happen if the Earth suddenly stopped spinning? Now, it's a fascinating question, isn't it? To understand the consequences of such an event, let's first dive into how Earth's rotation works and why it's so vital. Earth, our home, is like a top perpetually spinning on its axis, making a full turn every 24 hours. This rotation is the reason we experience a day-night cycle, a fundamental rhythm of life on Earth. As Earth rotates, different parts of our planet are exposed to the sun's rays, giving us daylight. And when we're turned away from the sun, we have night. But the rotation does more than just separate day from night. It also plays a significant role in distributing solar energy across the planet. It's not just about light and dark, it's about heat and cold too. The sun's energy isn't spread evenly across Earth. Instead, the equatorial regions receive the most direct sunlight, and thus the most heat. Meanwhile, the poles get less direct sunlight, making them colder. This heat distribution is crucial in shaping our planet's climate and weather patterns. Moreover, Earth's rotation isn't a solitary dance. We're waltzing in sync with our atmosphere and oceans. This dance helps move heat from the equator towards the poles, moderating temperatures and creating a more habitable world. In essence, Earth's spin is a life-sustaining cosmic ballet, choreographing our planet's climate and orchestrating the rhythm of life as we know it. It's a fundamental aspect of our planet, so integral that we often take it for granted. But let's indulge in a thought experiment. Imagine for a moment that the Earth stopped spinning. What would happen? Well, the consequences would be drastic, catastrophic even, leading to changes that are hard to comprehend. But let's try to understand them one step at a time. Stay with us as we venture into this fascinating, albeit hypothetical scenario. Firstly, we would experience extreme climate changes. Imagine a world where our familiar day-night cycle no longer exists. Instead, one half of our planet is locked in perpetual daylight and the other in eternal darkness. Without the rotation of the Earth to distribute solar energy, the side facing the sun would become increasingly hot. Temperatures would soar, making it inhospitable for most forms of life. At the same time, the side turned away from the sun would be plunged into an enduring night. Temperatures would plummet, creating an icy wasteland. Picture the coldest winter night you've ever experienced, then imagine it never ending. Such extreme temperature differences between the two sides of the planet would not only make life as we know it impossible, but would also drastically affect our ecosystems. On the sunlit side, the relentless heat would likely lead to widespread desertification. Water would evaporate at an unprecedented rate, and without nightfall to cool things down, there would be no relief from the sweltering conditions. On the dark side, the constant cold would freeze the surface of the Earth, creating an expansive ice desert. The perpetual darkness would also mean no photosynthesis, spelling disaster for plants and, subsequently, for the entire food chain. Such extreme and unvarying conditions would also affect the Earth's air currents. Normally, the heating and cooling of the Earth's surface generate winds. But in this scenario, the hot air on the sunlit side would rise and move towards the cold side, while the cold air from the dark side would flow towards the hot side, creating intense, ceaseless winds. These winds wouldn't be the gentle breezes we're familiar with. They would be more akin to the jet stream, a high-speed air current that influences our weather. Picture a world where these super winds are a constant feature, drastically affecting weather patterns and making conditions even more inhospitable. But that's not all. There would be more drastic changes. A halt in Earth's rotation would also lead to severe storms and extreme climate variations. A spinning Earth isn't just about giving us day and night. It's also the maestro, conducting the orchestra of atmospheric and oceanic circulations. These circulations are essential in distributing heat around the planet, thereby maintaining a balance in our climate. Imagine the Earth as a giant spinning top. As it spins, it generates forces that influence the movement of air and water. These forces, known as Coriolis forces, cause winds and ocean currents to curve, creating patterns that help distribute heat from the equator to the poles. This distribution is a critical part of what makes our planet's climate livable. But what would happen if the maestro were to suddenly stop conducting? If our planet stopped spinning, The Coriolis forces would disappear. Without these forces, the patterns of atmospheric and oceanic circulation would be disrupted. The harmonious symphony of currents and winds would descend into chaos. Without the usual patterns of heat distribution, the climate would start to experience extreme variations. Areas that were once temperate might become unbearably hot or bone-chillingly cold. The change wouldn't be gradual either. It would be as sudden and violent as a lightning bolt. The disruption in heat distribution wouldn't just result in temperature extremes. It would also give rise to severe storms. With no rotation to guide them, winds would whip up into violent tempests. The oceans, too, would roil with tumultuous currents, giving birth to monstrous waves and storms. In such a world, hurricanes and tornadoes would be the norm rather than the exception. Extreme weather events, which we currently consider anomalies, would become everyday occurrences. Life, as we know it, would face an onslaught of relentless storms and extreme climatic conditions. The cessation of Earth's spin would transform our planet into a land of climatic extremes and unending storms. It's a chilling scenario to ponder, but it underscores the vital role that Earth's rotation plays in maintaining our climate and weather patterns. If the storms don't get you, the change in Earth's shape might. Did you know that the Earth isn't perfectly round? Quite the contrary, it's an oblate spheroid, a shape that resembles a slightly squashed sphere. This is all thanks to the Earth's rotation. As our planet spins on its axis, it experiences a phenomenon known as centrifugal force. This force is stronger at the equator, causing the Earth to bulge slightly at its middle. Picture a pizza dough spinning in the air. The spinning motion causes the dough to flatten and widen in the middle, right? The same principle applies to our planet. Now, what if the spinning stopped? Well, without rotation, the centrifugal force that pushes outwards at the equator would cease. As a result, the Earth would gradually become more spherical over time. The planet would essentially shrink at the equator and expand at the poles. This shift in shape would have dramatic consequences for the distribution of the Earth's oceans and land masses. Let's dive a bit deeper into this. When the Earth becomes more spherical, the oceans, being fluid, would redistribute towards the poles. This could potentially submerge existing land masses near the poles under vast new oceans. Simultaneously, the receding waters of the equator could reveal new land masses that were once hidden beneath the sea. The reshaping of our planet would also impact the gravitational field, causing it to become more uniform. This could lead to a redistribution of Earth's atmosphere, with more air pressure at the poles and less at the equator. In a nutshell, the cessation of Earth's rotation would lead to a massive global makeover. We would see a shift in the geographical layout of our planet that would make current world maps obsolete. The changes in Earth's shape, the redistribution of oceans and land masses, and the alteration of the gravitational field would alter our planet in ways that are difficult to fathom. And if you thought the weather was bad before, just wait. The cessation of Earth's spin would not only reshape our planet physically, but also wreak havoc on our weather systems. But that's a story for the next scene. Stay tuned. Lastly, we would see a disruption of ocean and atmospheric circulation. The Earth's rotation is like a maestro conducting a symphony of currents, both in our oceans and atmosphere. These currents, including the Gulf Stream in the Atlantic and the jet stream in the atmosphere, play a vital role in regulating our planet's climate and weather patterns. Imagine them as Earth's heating and air conditioning system, distributing warm and cold air and water around the globe. But what if the maestro were to put down his baton? If the Earth stopped spinning, these currents would be disrupted. The consequences: rising sea levels for one as the oceans redistribute. But also we'd see altered precipitation patterns, with some areas experiencing extreme rainfall while others might face severe droughts. A world without the Earth's rotation would be a world out of balance. In short, the Earth would become uninhabitable. In sum, if the Earth were to suddenly stop spinning, the effects would be catastrophic. The ceaseless spin of our planet plays a vital role in maintaining the equilibrium of our environment. A halt in rotation would trigger extreme climate changes, with one side of the Earth broiling under perpetual daylight and the other freezing in endless darkness. The absence of rotation would also wreak havoc on our weather systems. We'd likely witness severe storms and extreme temperature variations alongside other unpredictable weather events. Additionally, Earth's shape, currently an oblate spheroid due to its spin, would gradually morph into a sphere. This could lead to significant shifts in ocean distribution and land masses. Moreover, the crucial ocean and atmospheric currents, driven by our planet's rotation, would be disrupted. This interruption could bring about severe climatic changes, including rising sea levels and altered precipitation patterns. Thankfully, such a scenario is purely hypothetical and not possible under the laws of physics. So for now, we can rest easy knowing our spinning Earth keeps life as we know it possible.